Here we go. So what is TypeScript? It's a new language, fairly new language, that was developed at Microsoft. Right now it's in version 0.95, which means it has not been publicly released yet. However, you can use it if you'd like. The idea behind TypeScript was articulated by Anders Hallsberg, who is one of the what's called the technical fellow at Microsoft in charge of languages. You probably have heard his name before, mostly in relationship with C# or VB. But he recently also talked about TypeScript. So the idea behind TypeScript is fairly simple. A lot of people think that JavaScript is kind of hard. And one can argue that point back and forth, and there are a lot of people who are very comfortable in JavaScript. However, certain things you have to do in JavaScript are just inherently hard. And that comes basically from what JavaScript is. At this point, it's a language that is roughly 20 years old that has not changed much in 20 years. And it lacks very, very important concepts that are quite common to vast majority of fourth generation languages such as C#, VB, or you can name pretty much almost any other language like C++ or Java. And those key concepts are classes mostly and interfaces, and some way to group classes into modules. In case of C# or .NET languages in general, we talk about assemblies, and of course we have classes and interfaces. That is not to say you cannot get away without those concepts, and people have for many years. But those concepts kind of lend themselves quite naturally to many business applications that we at Tyler here develop. And the reason for that is because when we talk about basic business concepts, they map usually quite cleanly to classes. They have some attributes that describe business process or a business entity, and they have some actions that those business entities perform. So that's the whole idea behind TypeScript. When it's all said and done, what comes out of TypeScript is idiomatic JavaScript. And because it follows best practices, the JavaScript that TypeScript compiler generates is fairly clean, and it follows accepted standards for modularity and object design and some other key concepts that JavaScript developers have gotten used to. For example, it will inject, if you use modules, it will inject the appropriate methods and properties and functions into a specified namespace instead of leaving it as a global object. And you will see that in a demo that we're going to run through. In addition to creating fairly clean JavaScript, it performs compile time tests that ensures that TypeScript that you write conforms to the intent. And the intent could be twofold. It could be implicit intent, where you don't specify, for example, type, or an explicit intent that you can tell TypeScript by using interfaces primarily. So interfaces is the way you tell the compiler what it is that you're trying to do. And if you do that, it will catch some of the simple mistakes that are so easy to make. And I myself made many, many times. And the most common one is really typos. It's fairly easy to mistype a function name somewhere, because JavaScript doesn't care if you mistype something, or pass in an incorrect parameter to a method that expects, for example, a number, but you pass it a string, and your code might actually work. It might not work all the time, but it might work. And those kind of mistakes TypeScript will catch before you run your application at quote-unquote compile time. The way that works is when you install TypeScript, which you can get from the link I have in my last slide, and you create a new web project, by the fact that you have TypeScript you installed on your machine, it will add an additional project task through basic CSproj or VBproj properties, pointing it to one of the compiler tasks, and in this case it will call TypeScript compiler or TSC exe, and that will do one thing. It will look for all of your TS or TypeScript files in the project and will compile them, generating corresponding JS files or JavaScript. And the important notion here is that TypeScript is purely design time language. You don't run TypeScript in the browser. Instead, you run JavaScript that TypeScript compiler generates. In addition to capturing some common errors at compile time, it also has much better IntelliSense support than almost any JavaScript tool you have. Because instead of guessing at what you're trying to do, which is what most JavaScript IntelliSense tools do, it actually will know the exact interface and exact method you're trying to call, and it will spot the errors right there as soon as you complete your line of code. And it will also give you a fairly good description of what it is that you're trying to do. So what's the reason to use TypeScript? And number one, to me, after using it for roughly about 6 months, I make far fewer errors than I did in JavaScript. And one important thing to notice is that if you don't know JavaScript as a language, you will likely struggle with TypeScript as well, because any JavaScript code you write is actually a valid TypeScript code. And you can confirm that by renaming any of your JS files, change the extension to TS, and run the TypeScript compiler, and 99.99% of the time it will compile successfully to JavaScript by really not changing much on anything. Of course, that's not the goal of the language. The goal is to make you more productive and make fewer mistakes. The way TypeScript derives IntelliSense and compile time intelligence is two ways. One, you can declare your interfaces right there in TS file, and as you use those interfaces, your compile time check-in will kick in. Alternatively, you can have an external TypeScript definition file. The convention is to use .d.ts extension, where D stands for definition. And those are files that don't contain any executable TypeScript, aka JavaScript code. All they have is TypeScript interfaces. So what happened in the past year, and I have a link right here on GitHub, there is a project called Definitely Typed. And what happened is the JavaScript developers who picked up TypeScript and saw the potential in the language, they started creating these external d.ts or definition files for existing JavaScript libraries. So if you go to that project, alternatively, you can always use NuGet. And if you use NuGet, just search for Definitely Typed, and you will see hundreds of definition files for all common JavaScript libraries. So far, I haven't found one that wasn't in it, and those would be things that you commonly use like Bootstrap or jQuery or Angular, or any common ones like um, time libraries and such, and many other JavaScript libraries. They're all in it. So for you to start using, say, jQuery from a TypeScript file, all you have to do is install that definition for jQuery, and you can, once you start typing like a $ dot, you will actually see, instead of seeing sort of rudimentary Studio IntelliSense, you will see TypeScript IntelliSense that is based on the definition file for jQuery. So it makes it very easy to get started. In other words, for you to get started and start using TypeScript on existing JavaScript project, all you have to do is install tooling, then download the definition files for those external libraries you use, create new .ts file, and just start typing TypeScript. And to refer to those files in your either HTML or in your bundles, if you're using bundling minification, you refer to it with a .js extension. In other words, my sample.ts after compilation will result in my sample.js file that you will actually include in your deployable solution. .ts file, as I mentioned before, and I want to reiterate, is just design time / compile time support. All that is going to be executed is generated JS file. So I'm pretty much done talking, and the rest of the time I want to do, what I want to do is write some TypeScript code to kind of demonstrate these concepts that you see on the next slide. And I'm going to keep slide minimized just to make sure I don't miss too many things here. So let's start with modules and type system. Here's a brand new web project. As you can see, there is nothing in it. I have a web page here that I'm going to use in my demo. And what you see here is that I have a demo start.js file included, and I actually have a squiggly line here that says you don't have that JS file inside your project, which I don't. But instead, I have demo start.ts, which is the TypeScript file that I'm going to type. In addition to that, if we look at library package manager, and I looked at the installed projects here, you will see that I have jQuery.TypeScript.definitely typed package installed, in addition to jQuery itself. So when I install jQuery package, of course, it just sits here in my project. However, the type-ins, and this is purely by convention, they go into type-ins folder, and that's how all definitely typed projects, NuGet packages work. They're all installed into type-ins folder. Then you have a subfolder for a specific library. And then you have that definition file I talked about. And this definition file simply defines the JavaScript that is included in my jQuery. And if I open it, what I will see is all the types and the methods that jQuery has. For example, here's the event object, and it has properties and types. So let's type our own. Let's start with modularity. Modules is an important concept that helps you organize your code a little bit better. To define a module, you simply use module keyword, followed by the module name. TypeScript supports dotted syntax, and it supports it properly, and you will see how in just a minute. Now what I want to do is define some kind of an interface so we can see type system. And I'm just going to call it a person, and I'm going to give it a first name. And now the way type system works, it uses syntax conventions that are common in ECMAScript 6 definition, which is a property name followed by colon followed by type. In my case, first name is obviously a string. So what you see here is something quite familiar to C# or Java developers, which is an interface with a name and properties. It doesn't have to be obviously just strings. I can add is active, and this is going to be a Boolean. One interesting thing to know that TypeScript really does not extend JavaScript type system. So there are only a handful of JavaScript type. You have basically a string and a number and a date, and that's about it. And you can use all of them here. So we can just say date hired here. And if I wanted to do date, I simply add a colon here followed by date. There is one more type that you can use, which is sort of important. And you think of any is not in the same way you think of var keyword in C#, for example. Any is closer related to a dynamic keyword in C#. And what you tell in TypeScript that this thing property can contain anything. When it comes to JavaScript, any property can contain anything. But in this case, by defining this interface, I'm declaring the intent. And my intent is that when I create a person class, what I want to have in it is a first name property of type string, not just a first name that I can shove a number into or a date or whatever else. So interface and type system is the primary way you define your intent. Of course, you're not limited to properties. We can also use functions. So we can say, we can change, for example, add like a last name here. Whoops. Let me do this. So let me add last name of type string as well. One thing that you will also notice that you obviously cannot have duplicate properties, so I should get an error right there, and it says you cannot have duplicate identifiers. So you already see some checking at design time inside the editor. Now how about I add a function? For example, I can say get full name. And that would be a function that would add first name and a last name. So that's my intent. So to define the intent, I can do it in a number of ways. I can use keyword function, and this could be any JavaScript function. However, there is an alternate syntax that looks like lambdas in C#. And here's how I would define a function without parameters and without return value. So I know that there are no parameters is because the parentheses are empty, and I know it has no return value, at least not a return value I care about, because I declare the return value to be void. Now I can change all that. So I can add parameters. So how about I add age, and this is going to be a number, which I have not used numbers before. And what I want to return is a string. So now I have a function that takes a number and returns a string. Now let's do something different. So we're going to talk about implementation in just a minute. And first what I want to do is define another module. And we'll take a look how modularity works in practice. Main.person. So here's a completely different module. Typically, I would not put them in the same TS file. I feel like it makes harder to find things. And obviously, you can put it in a separate one, but it's a little bit easier for the demo to keep them in the same file. So in here, we're going to cover the next concept. And the next concept is going to be a class. and we're going to call it person. Now, there are a couple of things that I can do. One, I want to make sure that my person is going to be an implementation of iPerson interface. To do that, I simply add keyword implements instead of the question mark, instead of a colon, as you would expect inside C#. And the reason for that is because colon has different meaning in TypeScript, closer to what JavaScript does. And as a result, we don't want to mix the meaning, so there are some additional keywords that are used here in TypeScript. You already see a squiggly, and the squiggly says, I cannot find symbol iPerson. And here's where modularity shines. You can choose, pick and choose what classes, interfaces, identifiers, entities, what entities in general you want to expose from a module. In this case, because I did not use public keyword, which is not technically public, I didn't use any other keyword inside my app.main module to qualify iPerson interface, so it's not visible outside app.main module. Let me copy this. You'll see what I'm talking about in a second. If I do this, I don't have any kind of a problem. It knows what iPerson is. It tells me that I don't have everything implemented, but it tells me I know what iPerson is. So to expose interfaces and classes outside of the module, you gotta qualify those entities with export keyword. What it allows you to do is decide what you want visible outside of a module and what you want to be hidden or private. Obviously, nothing is technically private. So when it comes to executing JavaScript, you can execute a private methods at any time you feel like it. But that's not your intent. And as a result, TypeScript will give you an error if you try to access a private field or private member in general of any class. So now it knows what person is. Let me change this for a minute. Because it sits inside the same app.main, I did not get this error I expected. Now that modules are sort of in parallel, one cannot see data exposed by the other, so I got the same error. I don't know what iPerson is, even though you can clearly see that it's now public. And what I'm dealing with here is that in TypeScript, I have to fully qualify my types with module names. Because technically speaking, that's where my types are. You probably did not see that, but if I hit dot, I actually have full-blown IntelliSense, and it tells me that inside main.interfaces, I have an interface called iPerson. And that's kind of useful. Not only that, but if I delete this, I actually have namespace, quote unquote, a navigation here as well, and IntelliSense is helping me out to discover that. Of course, this is kind of a lot of typing. So in addition to export keyword, there is also import keyword. And what import keyword allows me to do is import identifiers from another module and alias them. So I don't have to call it iPerson. I always do. I like that. But now that I imported that, I can delete fully qualified type out and replace it with just iPerson. So you think about it in terms of export has a corresponding import keyword, and that keyword allows me to use shorter type names. The way to think about import is sort of a import keyword inside Visual Basic.NET. It does exact same thing. It sort of brings in the namespaces. The intent is different. The intent is the same. Syntax is slightly different. Now, what's my next error? What my next error is, I declared that my interface has all these members, but my person class does not have any of them. So I immediately get the same error I would have gotten in C# that says, I'm not sure what you're trying to do here, but you have not implemented your contract. So I'm going to delete a few things so I don't quite have to type as much. So now I can take my contract, put it here inside my class, and my error went away. Now my class that implements iPerson has all the members. Of course, it obviously doesn't have any code. It just has member declarations. Now I have to add some code to it. There is nothing I need to add for properties. They are what they are. However, I have a function declaration here called getFullName that does not have any code. I haven't written any. So typically, I would create the code inside the constructor. And constructor, as name implies, is just a constructor for a class, another new keyword from TypeScript. And inside here, I can fill in the details that are missing. Immediately in the IntelliSense, I see all my defined members, and I'm going to fill in getFullName. It adds a parentheses, but I think that's the issue with ReSharper. They have some bugs in TypeScript editor. And in here, I'm going to have a function, so I can go ahead and copy function definition here, so I don't make a mistake. And after that, I'm back to C# code. I just have to fill in the details of my function. So I have one parameter, age. Again, I got the error, and the error says, you said you want to return a string, but you actually are returning void. So I have to make sure I return the same return type that I defined here. In here I can return simply this dot last name plus comma, so this is kind of trivial, plus this dot first name. Now I have my return value. And now all my errors went away because I'm returning what I specified in my function contract. How about if I try to return age? I got an error that says I cannot convert number to a string. So here's the compile time check-in in action. I have to return the proper thing. Now there is one thing to notice. You don't have to return primitives at all. So for example, I can add another property. We're going to call it parent, and it's going to be of type of iPerson. And I might return another iPerson. In other words, parameters and return values of function and in type system in general could be anything. They don't have to be primitives. Now, if I want to use this age parameter, I can also add that, plus we're going to do a space, plus we're going to add age. There is some automatic type conversion that takes place in here, so this thing works. But I can also do that, so I can add age. There is one more concept that goes with type system, and that concept is of nullable types. So in JavaScript, just about anything could be null. However, my intent is that I declare here, I'd like to see first name and last name to be populated. So they're sort of a mandatory members. And the way you will see that, let me create another module, and I'll demonstrate that. app.main.demo, and we can say var person would be main.app, no, is it app.main.interfaces.iPerson, and I want it to be, I want to use object literal to initialize this person. And what you will see, it says, you said that person, or iPerson more specifically, has first name. And you told me that first name was mandatory. So you must, when you use object literal, specify this first name. I can get around that by adding a question mark, which is exact same syntax that C# is using for nullable types, except the question mark goes on an identifier, not on a type. But if I move my mouse over here, first name error went away, and now I have last name. And if I do this, then my last name went away as well. And now all I have to do is define a function. And I can make that nullable, and now my person is happy. However, I can still say first name is equal to John. And this is still valid syntax. However, if I mistype that and I do first name 1, even though it didn't give me an error again, I think that's a resharper problem. If I try to compile it, it will give me an error saying first name property does not exist. But you see that I'm being pushed into certain constraints that are defined based on my intents when declaring interfaces. So now I have a full name done. Now I can also do a couple more things. I can do certain things in a constructor. For example, I can take my initial first name here and last name even. And then I can say this dot first name equal first name. So inside the constructor, I can immediately initialize my object with whatever passed into the constructor. Not only that, but I can pass some information that I simply need. I'm not sure for what reason, but that could be a reason. So maybe I want to pass in age, which could be any, for example. So we can use any, which means in the constructor, I can pass in whatever I want. And if we change that, we're going to say I want to create new dot person. Oh, and here's my error back again. I don't see my person class inside my IntelliSense. It's exact same problem. I did not export it out. Now there is a person here. Again, IntelliSense is there. It tells me, hey, you need a first name and a last name to pass in to my constructor. So I can do John, passing Doe. Whoops. I needed equal sign here. That's a little better. And I need to say that this, technically I should do this. And then it says, oh, by the way, you said you wanted age. So because age is any, I can pass in new date, for example. And it's just as happy as can be. However, if I change age to be a number, now it says, hey, I don't know what you're trying to do, but you cannot pass date because I expect a number. However, if I pass in 12, now it's quite happy again. Now let's see how we can use jQuery in this circumstance while we're on the topic. So let me call jQuery here. I'm going to declare ready function. And I'm going to grab something off my page. I'm going to grab this span right here. And I'm going to set its content to my person. So let's see if all this code works okay. So let me run that and see if it does anything useful. So what you saw is that I created this object, person object, with a first name John and a last name Doe, which is exactly what I did here. So my TypeScript got converted to JavaScript at some point, because obviously inside here I want to use demostar.js, not TS. So if I'm going to go ahead and open JS file, I did not create this JS file. It was automatically generated for me. And what I want to show you guys is that JavaScript that was generated is pretty standard. You probably have seen the self-executing function module pattern, where you sort of walk the stack of modules. And what it's trying to do is going to say, if I don't have global object called app, I will create one. If I see one, I'm going to use it. The next, do I have an object called main, or more exactly a member called main, on my app object, which is right here. And if I don't have app.main, I will create new one, otherwise I'll pass it in. So this is pretty idiomatic JavaScript, as I was mentioning. And all this stuff, like the only thing I actually will use is this. The rest of it, which is about 8 lines of JavaScript, is pure plumbing to support best JavaScript practices, which is to group all of your data into namespaces so you don't have object literals and functions and variables hanging off the global object where some other library can stomp on your function just because it's named the same way. So instead of writing those 8 lines of JavaScript, I just use 1 line of TypeScript that says module. And it results in exact code that I want to use. Let me look at the slides right quick to see if I missed anything. So we talked about modules, we talked about type system, classes, export and import, functions with and without parameters and values. We talked about constructor. We haven't talked about generics or, so to speak, smart constructors. So let me create another class, export class thing. And I'm going to add a constructor here. And I'm going to take name, which is a string, on my constructor. So now I don't have any errors. I'm going to close JS file. So in here I can say var thing is equal new app.main.person.thing, and I have a name. Now if I hit thing dot, I don't have any properties, including name. And here's some shortcuts that constructor keyword offers. For example, I can say this name is going to be private. Now if I type thing here again, you see that the name now shows up. However, I cannot assign stuff to it. You got an error. It says it's not accessible. Now to make it accessible, we can change private keyword to public, and immediately my error went away. So what that allows you to do with the smart constructors, you can define properties straight inside that constructor. And it saves you some typing, and consequently probably save you some typos. Finally, let's look at generics. Let's gonna do another class. We're gonna call it result, for example. So say you call in some service, maybe a web API, and it returns complex result set, which will have, for example, always have an error property and a result. Then in JavaScript, you can say, hey, if I have an error, I need to show an error, otherwise I'll process the result. So now I can have a generic class of result, and I can say I have error message, which is going to be a string, and I can have a result, which is going to be of type T. So it's almost exact C# syntax. And now when I use it, I can say, well, result, this is going to be app of type app.main.person.result of, I don't know, string equal new, and I have to type a little bit. I can do this, or I can just do this, which is a lot less work. And I can say error message, where is it? Error message would be null. And result could be 22. Whoops. There we go. Oh yeah. Switching languages is a little rough. And it says, oh, result, you shove the result of, you shoved 22, which is obviously a number, into result, but you said that your result should be of type string. So now there is more compile time checking here. Not only that, but I could say, oh, by the way, maybe a result is this. So generics work exact same way as generics work in C#. I should get another error if I build it, because the result should be checking to see if I got a person. So it makes it a little bit easier for you to have reusable types that are of certain generics. Not only that, but you can also have generic functions. So I can say do something, which is going to be a function, and the function could also be of type whatever, of type T. So that the I think actually goes here, and this would be a function that returns T. Like I obviously forgot the syntax, but function just as classes could be generics as well, and that's kind of opens things up to where you can do constrained parameters, two functions or two classes that are constrained by a generic type that you declare as part of the function definition. I'm trying to think the exact syntax here, and I just don't remember it. But we can look it up later. You can definitely have generic functions though. So I think it's 11:45. I'm going to jump back to slides for a minute and do sort of a recap. So you can find more information on typescriptlang.org. I will post the slides and the recording up on this link somewhere. I already have my previous presentation there. In case you missed it and you're interested, that was the introduction to Angular. To recap, and I'm speaking now from my own experience, I started using TypeScript in August, And honestly, I was a little skeptical because I did not feel that JavaScript needed improvement. It needed to be taken care of with and following the patterns, but I did not honestly feel like I need to improve upon it. However, after using TypeScript for a few months, I find myself that I'm being more productive, both by making fewer typos and fewer mistakes in general, as well as taking advantage of better IntelliSense. I also find that JavaScript that I generated, that in the first maybe like month, I was actually looking at generated JavaScript code all the time because I wanted to see what they do and how I would have done it differently. But after about a month, I stopped doing that because I could never see any issues with generated JavaScript, and I have not run into any problems. And that's really my story. When it comes to debugging, you can actually set up breakpoints inside TypeScript files, inside Visual Studio. And initially, that's all you had. But I know I was able to debug TypeScript files in Chrome tools as well directly. And the reason that that works is because in addition to generating JS file, TypeScript compiler also creates a mapping file between the two. And it says it's not a human readable file, but it's something that debugging tools, at least in Chrome, understand. I haven't tried other browsers. I'd be kind of surprised if it worked in IE. Probably not until version 11, but it definitely works inside Chrome. And that will allow you to debug TypeScript code that directly. I find myself setting breakpoints in both TypeScript and JavaScript files kind of interchangeably. And I think that's part of the habit of dealing with JavaScript for so long, where sometimes I just find it easier. I can't really tell why. And so these are all the key features that I try to show you. It should ship, I think, pretty soon. I suspect that 0.95 was probably the last beta release, and Microsoft got a lot of feedback. If you want to look at any discussions, you can look on Codeplex. That's where TypeScript project is hosted. It is completely open source, so if you want to download and play with the TypeScript source code compiler, you can. It comes in addition to compiler. It also comes obviously with Visual Studio tools. But everything is open source, and one thing that is interesting to notice, if you at some point are getting tired of TypeScript, you can still use whatever it generated for you, because what you're including in your application is generated JavaScript files. I think that's all I wanted to talk about today. Hopefully I gave you guys good overview and hopefully relate some of my excitement because I try to share things that I think are useful in a daily developer's life. So I'm going to unmute everybody, and if you have any questions, go ahead and speak up.
Are you guys using this in production already?
Are we using it in production already? Yes.
Yes.
Not in a very large project. It's sort of a small project, and we are using it on beginnings of a big project that we started a little while ago, but it has not shipped and won't shipped for a while.
Are you using it like in conjunction with Angular or?
Yes, we're using it in conjunction with Angular. If you guys are interested in how that works, I can add some links to some sample demo projects I created on my own time that you can download and see how that specific demo is using it. You might choose to do it differently, but it works great with Angular, in my opinion anyway.
Yeah, could you provide those links?
Sure. I will provide those links on the PowerPoint download links, and you can just download it. If you have any questions, let me know. Anybody else?
What if I make change to the JS file? First, I go in there and custom type in a small function or a variable that I use, and when I recompile the TypeScript, is it going to overwrite file?
Yep. The question is, can you edit the generated JS file? And yes, you can, but as soon as you save the TS file, it will be overwritten. So really, once you go TS, you should really stay there. You should not try to alter what it generates. If you want to do that, then the TypeScript really has no value. But as I mentioned before, and I want to kind of stress it again, you can mix and match TS and JS files in the same web project without any issues. As long as you're bundling or minification or whatever you're using, or direct references will reference the JS output files, you're fine. And you can mix and match, and you can have bulk of your project in JavaScript and still start using TypeScript, and without really any cost prohibitive really hoops you have to jump through. Literally, you install the tools and you right click and say, I want to add new TS file, and then you simply add the output JS file inside your either bundling, minification, or web pages, and it works. If you're using automated builds, you have to make sure that you install TypeScript tools on the build machine, though, or those TypeScript won't compile. And the other thing, if you're using TFS, don't include JS files in source code, or again, you're going to have build problems because they're going to be read-only. So in the project we're using, the only stuff that is in source code is TS files. Yep, you can import from one module to the other. Okay, so the question is, if you want to use an existing JavaScript object inside of TypeScript file. And so you have two options there. One, you can simply declare it as of type any and just use it as is. Of course, you won't get any IntelliSense. Or you can add .d.ts or TypeScript definition for the object from another JavaScript file. You really don't even have to link the two. You just have to have definition, because those definition files are simply used at design time. And so TypeScript is not even going to look at your JS file. It's just going to say, oh, you have another definition, and I see this object that has a method called compute stuff. I can just create d.ts file with that object and that method, import it in my TS file, and I can start using those methods. But you would, and that would be the route you would go. Obviously, generating TypeScript definitions for a ginormous project is kind of too expensive. But if you have maybe utilities module that has maybe 20 functions in it, that would be actually fairly trivial effort to create definition file. It may take you an hour or two. And then you can start using that utilities module everywhere else in all of your TypeScript files. Any other questions? Thank you, guys. I will email the link just in case to everybody who accepted the invite, and I'll put it in the same location, and I just need a few minutes to process the video, and I'll post it all hopefully later on today. I appreciate everybody's time, and you guys have a good day.